Now more than ever, innovative technologies are fueling change and sparking new ways of thinking. Collaboration between corporations and startups is key to staying at the forefront of these trends. However, finding the right startups can be expensive, time-consuming, and ineffective. But Plug and Play is here to help. As a corporate partner, you will gain access to a whole ecosystem of innovation. Discover startups that meet your tech interests. Stay updated on the latest trends and network with industry peers. We will help you during every stage of your innovation journey, no matter where you are and where you want to go. Get in touch today.
Well, welcome everybody. Great to have you all here today, and welcome to Climate Tech Innovation Showcase. Again, it's great to have you all here, and we've done this type of events in the past, and this is going to be our 6th event. Can't believe it's been already 3 months since we had our last one, but we're super excited to showcase how some of the major energy corporations are working with global climate tech startups towards Net Zero Japan. I'd like to welcome you all, and so I just want to, okay, my name is Juni. I'm with Plug and Play. I'm a partner success team, and just wanted to go over today's agenda quickly. So after the opening remarks, we're gonna have a company introduction pitch by Tsunami BHP. They are a modular ammonia production startup that span out of Tokyo Institute of Technology. And then after that, we're going to have a collaborative presentation by H-Cycle, ENEOS, and Idemitsu. H-Cycle is a waste to hydrogen startup, and then ENEOS and Idemitsu are both major oil and gas companies from Japan. And after that, we're going to have a fireside chat with Eavor, a geothermal startup, and also Chubu Electric. And then we're going to close out the session. So just a bit of a housekeeping item here. I know you guys see both the chat box and also the Q&A box, but if you guys have any questions, make sure to turn them in. Make sure to submit your questions in the Q&A box, not the chat box, so our presenters can answer them as they go, or they can address them by typing their answers afterwards. So make sure to do that. And for those of you who are not familiar with Plug and Play, I just want to quickly go over who we are and what we do. So we're, Plug and Play is a venture capital. So we investing about 200 early stage B2B startups every year. We have over 1,600 startups in our portfolio. And also we run startup accelerator programs in over 20 industries. And we're also a corporate innovation platform. As I said, we have over 1,600 startups in our portfolio, and over 30 of them achieve the unicorn status. And again, we have many industry-specific programs, and today we're focusing on energy and decarbonization. And we have pretty large global footprint, so we basically have offices in most of the major cities in the world. And one of the recent ones would be the office in Phoenix, Arizona. We're focusing on semiconductors and aerospace engineering. And we work with over 550 large corporations from all over the world, and they are here in our ecosystem to find the nascent technologies and to find startups to work with or to invest in. We're excited to showcase some of the successes they had in the past few years. And I just wanted to touch a little bit upon our climate tech event. So we've been having this type of event in the past 4 years. We've done in-person ones, we've done webinars, and this is going to be our 6th event. The primary goal of this event is to connect global energy corporations with climate tech startups. So we're excited to see more collaborations between large corporations and startups all over the world. And I don't want to take, sorry, I just want to move on to the next slide. I don't want to take too much of your time here, so I'm just going to pass it over to the first speaker of today. We've invited Tomo-san from Tsubame BHP. As I said, they are a modular ammonia production startup that span out of Tokyo Institute of Technology. With that, I'd like to welcome Tomo-san. And let me stop sharing the screen.
Yep. Thank you, Juichi-san. And hello, everybody. This is Tomoyuki Koide. I'm from the Tsubame BHP. We are the Japanese startup of the ammonia technology. And currently, we are focusing on the US market development. So I'm very glad to have an opportunity to talk about our technology here today. So I'm starting my presentation, and then let me explain about our company and our technology. So Tsubame BHP is ammonia production technology, which is low temperature and lower pressure ammonia synthesis technology. And then based on this technology, we offer the distributed green ammonia production solution. So what we want to achieve is 2 points. One is decarbonize ammonia industry. So current ammonia, which is produced based on the fossil fuel, and then emitting lots of the CO2 during the production. Then we want to provide our solution to small scale green ammonia production, which could remove the CO2 emission in the ammonia production. The other point is distributed ammonia production. So current ammonia, which is widely used in all over the world and also all over in the US, but there is a lot of the ammonia transportation. So our concept is on-site ammonia production, which could produce ammonia in locally, where we can remove this kind of ammonia supply chain. So let me briefly explain about the ammonia market itself. So current ammonia is already 180 million tons is produced. So which is quite big a volume of the ammonia is already produced. So which ammonia is one of the basic chemical. And 80% of this is used as a fertilizer. So ammonia is quite essential for the food production currently. But not only for this existing market, there's a potentially big market in near future. So there's two new applications. One is a clean fuel. So ammonia can be used as a fuel without CO2 emission. Potentially, it can be used as a maritime fuel for the vessels and also for the fuel of coal power plant, where Japan and Korea officially announced to use ammonia as a fuel. And the other potential is a hydrogen carrier. So hydrogen is very difficult to transport, and ammonia can be one of the media to store and deliver hydrogen. Here is the reason why Tsubame BHP is interested in the US North American market. There is 3 reasons behind. Number one is the ammonia market itself. So agriculture is one of the big industry in the US. So large volume of the ammonia is currently used as a fertilizer. And also for ammonia, as I mentioned, the US is a wide country, so ammonia transportation is needed. So there is a high inland transportation cost, as well as there is a safety concern of this kind of ground transportations. Secondly, the renewable energy has a strong competitiveness in the US, where the solar power and the wind power has a good potential, and then cheap price of the renewable energy can be produced in the US. Number 3 is IRA, Inflation Reduction Act, and then there is a potential subsidy on the green hydrogen, and then the maximum value of this subsidy can be $530 per ton of ammonia, which is quite a strong benefit for the ammonia end user. So here, there is the reason why. So what we want to achieve is, again, I want to highlight is removing the CO2 emission. So current ammonia, which is emitting more than 1% of the CO2 in the global emission. So as I mentioned, the current ammonia, which is produced from the gas, oil, or coal, and then during the production of ammonia, there is a CO2 emission, and then this is called green ammonia. But if we could convert, we could shift to the green ammonia or blue ammonia production, we can remove this kind of CO2 emission. So green ammonia, which is produced from the renewable energy, such as solar power, wind power, and then green ammonia can be produced with Tsubame's technology, and then we can remove this kind of CO2 emission. Secondly, the supply chain, we are trying to remove the supply chain by on-site ammonia production solution. So current ammonia, which requires long transportation, and such as like a vessel by barge, and there's a tank, and then there's like a tank lorry to deliver to the ammonia end user. So there is an additional transportation and ammonia storage cost, and also the supply risk of the delivery interruption by long supply chain. So if we could achieve the on-site ammonia production, which means that just like producing ammonia at the consumption point, so we can remove this kind of like a supply chain cost, and also for ammonia supply will be stable. That's what we want to achieve. So here is a detail about our like a green ammonia production solution. So again, let me explain about like how to produce green ammonia. So the renewable energy, such as like a solar power or wind power, could produce the renewable electricity. And then this electricity goes into the electrolyzer, which produce the hydrogen, which is called green hydrogen, by electrolyzer, by splitting water. And Tsubame have a solution of this small-scale ammonia production system, which use this hydrogen and nitrogen as a source of the raw material, and then ammonia can be produced inside of our system. Then green ammonia can be produced, and then there is no CO2 emission during this process. And here is our lineup of a small-scale ammonia production system. So this modular system, we have a 3 lineup: TM500. 3,000 and 5,000, and which could produce each number's ton per year capacity. For example, like a TM5,000, which could produce 5,000 ton per year level. And here is a reference and the size and the capex image. And the larger size of this modular system, we are capable to supply. We call it as a plant system. We are capable to supply between 10,000 to 50,000 ton per year level. And in future, we plan to expand this capacity limitation to much higher, like 10,000 ton per year level. And here is our core technology, which is called electrolyte catalyst technologies. So we are a startup company from Tokyo Institute of Technology. So the professor in this university, he has a technology of this electrolyte catalyst technology. So this electrolyte catalyst, which is containing electron inside. And then ammonia is produced from nitrogen and hydrogen. And the nitrogen has a triple bonding here. And then cutting this nitrogen's triple bonding is one of the key process of ammonia synthesis. And then this electron inside of the catalyst, which works as a scissors to cutting this nitrogen's bonding. So because of this one, so ammonia conventional technology is called Haber-Bosch process, and which has a history of more than 100 years. But this Haber-Bosch process, which requires high pressure and high temperature for the reaction. Because of this electrolyte catalyst electrons behavior, Tsubame's process, which requires much lower pressure and lower temperature for the reaction. Because of this characteristic, lower temperature and lower pressure ammonia synthesis, we have an advantage on the small-scale ammonia production system. So we focus on developing this small-scale ammonia production system. And this is the last page of my presentation. So let me explain about our status of the company. So our company, Tsubame BHP, established in 2017, and then we focus on the catalyst industrialization, which means we established how to manufacture the catalyst. Once we could produce some volume of the catalyst, so we constructed our pilot plant, and then this pilot plant started the operation in end of 2019. Then this pilot plant is running more than 3 years in Japan, and this capacity itself is like a 20 ton per year level. And then finally, end of last year, we received the first commercial plant order. And currently we are doing the EPC for this first project, and then which plan to start in 2025. This first plant is the location is in Japan, and the capacity is a TM500, which means 500 ton per year, the smallest modular system. So currently we are doing the EPC for this project, but not only for this one. In terms of the business development, we are quite interested in the North America. So currently we are developing the market, and then we are trying to find a partner to work together in North America. That's the end of my presentation. Thank you very much.
Thank you so much, Tomo-san. I think we have a couple questions in the Q&A box, so maybe we can pick a few. So the first one would be, how will the project of green ammonia support improvement of social well-being of Japan's population, or how does it contribute to the reduction of social disparity in Japan? Might be a little tough question, but yeah, if you have any thoughts around there.
Yeah. One of the Japanese government, they officially announced to use ammonia as a fuel in 2020, which is to use ammonia as a fuel for coal fire plant. The reason why is the coal power plant, which is emitting lots of the CO2 emission. But using ammonia, some of the green ammonia as a fuel, which could reduce the CO2 emission of that coal power plant. So this ammonia technology could contribute to those kind of environment, CO2 emission reduction. So Tsubame's people is also excited to develop our technology and then deliver our technology to contribute to such a point for the CO2 emission in the global.
Thank you, Tomo-san. I know a lot of energy companies are also looking into green hydrogen production, so I think there's also a lot of opportunities out there to collaborate with. Let's get to another the next question. Is it possible to scale down the solution to be applicable to residential solar power applications?
So we already have several lineup of this modular system, and the smallest one is a TM500. Even for TM500, we need a certain volume of the renewable energy. So a residential, maybe solar, is not sufficient enough to produce the required electricity. And so basically, but we think that this one is the smallest, TM500 is the smallest one to have a feasible economics. So maybe it may be difficult in such a residential scale to produce ammonia in a small scale.
Gotcha. Maybe in the future. And yeah, I guess it ties into the size of your modular production, but what is the size of the first commercial plant you are currently building?
Which is we also have some a press release, and then this one is a TM500, so 500 ton per year capacity one is our first plant.
Sorry, I'm just clicking. You have so many more questions, which is great.
Right. Yes.
What is the average cost and time of setting up your mid-sized model?
Very roughly, the estimated cost is shown here for this module system, and this can be the reference. And then regarding a schedule, it takes about 18 to 24 months, which means 1.5 to 2 years to install this kind of ammonia system.
Okay. Yeah, there's so many more coming. How does the cost of the ammonia compared to conventional processes? I know using green hydrogen might, we imagine might go up a little bit, but yeah, if you can touch a little bit upon the pricing.
Yeah, that's a quite important point, we think. And so first of all, the important point is this price of the hydrogen, price of the renewable energy is quite important. And current ammonia price, gray ammonia price in the market is quite low. So we need competitive hydrogen and renewable energy to produce on-site green ammonia. That's an important point. So we need a good source of the hydrogen renewable energy. And then answering to the question, so compare with this conventional process, as I show here, that because of this reaction pressure and temperature requirement is quite low, basically we have an advantage on the capex. So capex itself is in a small scale, compared with conventional Haber-Bosch process. We have a much cheaper, we think we have a much cheaper solution, and then which could contribute to reduce the small-scale green ammonia production.
Thank you. Who will be managing the modular ammonia units near farms? Are you guys deploying engineer teams, or will be managing those units?
Yeah, this is also the important point. And so Tsubame BHP is an ammonia technology provider. So we provide our technology, and then we need other organization to operate and monitor the system itself. So that's like a quite important point. Who will take care about this ammonia production system? So, but because of this is a small scale, and then as much as possible, we install the automations. So basically, they don't need much operation during the production. So some of the people need to monitor the system itself. And also for the maintenance, this one is a typical chemical, small scale chemical plants. So in the US already there's established like a chemical industry. So many like manufacturing company who could support and cover this kind of like a maintenance of these kind of equipments and the machineries.
Okay. Also, as a potential business partner in Florida, who are the best prospects for this ammonia technology?
We need several like partners to organize this kind of like a green ammonia project. First of all, as I mentioned, the solar power, renewable energy is needed. So I'm interested to talk and collaborate with renewable energy company or hydrogen company who plan to produce hydrogen. And also we are looking for the like off-taker end user finally who will offtake the ammonia. So in many cases, it can be the agriculture organization, but not only for that one, chemical industry are also using the ammonia. So I'm also interested to talk with those kind of current ammonia users.
Awesome. Yeah, maybe you can drop your contact information in the chat box after this too, so they can get in touch with you. Let's get. Well, let's pick a few other questions. Let's see. What kind of IP is available to license?
Yeah, so our core technology itself is this catalyst system, and then this catalyst we have an IP already. So usage of this catalyst, we license our catalyst technology. Okay,
thank you. Yeah, we have two other questions, so let's get to all of it. Have you done a commercial evaluation? What is the per kilogram cost you aim to achieve, let's say by 2030?
Right. So we did several like analysis and the feasibility study to evaluate the cost. So it totally depends on the location or like the projects. So case by case, we do some like calculation and then we show to the customer. So yeah, source of the hydrogen is quite important. So based on that one, yeah, we calculate. So yeah, answering to your question, unfortunately, it's just like a case by case, and then we can discuss separately, like what's your idea of the like a project, and then based on that, we can calculate.
Okay. Okay, this is going to be our last question. What is energy efficiency of the solution? Is it better than the Haber-Bosch process efficiency?
Yeah, so efficiency itself, so as shown here, the reaction pressure and temperature is lower, and then which has a benefit on the capex, like a system itself in the small scale. In the small scale, like a high pressure and high temperature requirement, which is difficult to produce the like a piping or like a equipment in the small size, then capex will increase in these kind of things. But lower pressure and the temperature, which is much easier to manufacture these kind of like a piping, valves, and equipment. So mainly the advantage is on the capex side, and then the detail of the number we can discuss separately offline.
Awesome. Well, thank you so much, Tomo-san. I'm gonna stop sharing. Okay. Yeah. So yeah, if any of you in the audience, if you guys want to get in touch with Tomo-san, I think he dropped his contact information in the chat box. And also we're gonna share the recording of this event after this. So yeah, thanks again, Tomo-san, for your presentation.
Thank you very much.
Yes. Okay, let's move on to the next section. I'm gonna share my screen once again. Okay. So up next, we have a collaborative presentation by H-Cycle, ENEOS, and Idemitsu. So H-Cycle, they transform solid waste into hydrogen, and Robu is going to be pitching today. And then Masa-san from ENEOS and Takumi-san from Idemitsu, they're going to be both talking about what they're also planning to do with H-Cycle. I believe ENEOS recently announced that they're going to be investing in H-Cycle. So let's hear more from Rob, Masa, and Takumi.
Great. Right. Thank you, Jun-san. And Tomo-san, thank you for your presentation. I'd like to talk to you about very cheap and very good carbon intensity hydrogen, okay? So, Jun, do you have the slide control so you can move to the... Like the previous speaker, H-Cycle has thought about how do we address climate change. And so we have chosen to be waste organic material as our feedstock to make cost competitive renewable hydrogen. Please advance the slide. If you think about the two segments that we are engaged in, on the one side, we're addressing a waste challenge. And in most of the world, the waste goes to landfill, which becomes methane. There are economies that do a very good job of trying to recycle or harvest that waste for electricity production, other things. We think that waste is more valuable as a hydrocarbon opposed to electricity. So we can talk about that. Of our two sides of the equation, on the one left side is the waste. It's about 3 to 4% of the greenhouse gas contribution today. And we thought, if we could harvest that waste, what do we do with it? And we chose to address the hydrogen market on the right side of the equation, which is also a contributor of 3 to 4% of the world's greenhouse gas emissions, primarily because it's made from coal and natural gas. So we use extractive fossil fuels today as a world economy to make the hydrogen that we use in all of our fuels and all of our ammonia and all of our other chemical feedstocks. If you put the two together, that's where H-Cycle is a business model, where we take organic waste materials, we extract the hydrogen, we don't make methane, so we get a huge avoided greenhouse gas number in our carbon accounting, and we make a very valuable hydrogen molecule for feedstock, for fuels, for chemicals, etc. Please go next slide. For the H-Cycle business model in general, we have these 6 theses that we talk about. One, we have a very proven management team. We are 12 people currently. We come out of the power and infrastructure business. You can see the resume numbers there. We have very interesting and aggressive investors in the space. So we have Azimuth Capital Management, and you might notice on the call today, we have one of our colleagues, Makoto Mizuyama, who is very active in the Japanese market as well. But also my partners at ENEOS and Idemitsu are going to present right after this. So we're very interested. We secured proprietary rights, number 2, to a thermal conversion process that's been proven, Canadian company that ran for 20 years. And so we've seen 3 levels of scale up of the technology. So we don't think we're taking a big technology risk. And it's a very efficient process. So when you think about things like electrolysis or other hydrogen production technologies, we are about 25% of the energy input. So we actually use the energetic value in the waste to create hydrogen. We don't take something like water and try to break it down, which is a destructive process. So we have a very cost competitive economic proposition. Third point, I think you all know, you're on this call, it's climate tech. It's about hydrogen as a vector for decarbonizing. Fantastic. Number four, very interesting business model. We actually have 4 revenue streams. Of course, we sell the molecule hydrogen. We sell low carbon credits. We get a PTC, or production tax credit, in the US. Different places monetize carbon different ways. But because we are a waste disposal option, we get paid for our feedstock. Almost no industry in the world gets paid like for their feedstock. So it's a very interesting revenue stream. Fifth, we have very compelling unit economics. I think there were some questions for Tomo-san before. We have a very, very compelling economic story because of these revenue streams, because of our low carbon intensity. It's negative, actually. And then lastly, we have a very robust pipeline of projects that includes the Western US, where we have exclusive rights on our technology. It includes Japan and Korea, where we have exclusive rights on our technology, which is why we're here today with Idemitsu and ENEOS. Next slide, please. Just want to give people the arc of our development. Our flagship project will be in the Bay Area of California, in San Francisco Bay Area. The city is actually called Pittsburgh. That will be ready for a final investment decision and a notice to proceed in second quarter of next year. But right behind that, we have multiple projects in development. And our approach has been not to try to line up projects in series, but instead line up projects in parallel, so that when the first one comes to COD, we have a lot of opportunities for investors to jump in behind it. We've established these joint ventures in Japan and Korea. That's very important because we acknowledge the progressive role that Japan has already played and South Korea has already played in taking the energy from waste to an electricity byproduct, which is great. We think it can be even more valuable as a hydrogen feedstock. There are lots of ways to make electricity cheaper than burning trash. We instead do a thermal conversion. It's not combustion. You can see here this progression from today out through 25, 2026, 27 of multiple projects hitting COD. And so we think it's a very interesting market for investors. Right now, we actually are raising money at the corporate level, getting ready for all the project deployment. But the ratio of project money to corporate money is, 100, right? We need 20 million to do the corporate stuff. We need 2 billion to do the project stuff. Just a general point there. And then lastly, I'll just summarize so I can give my colleagues from ENEOS and Idemitsu the floor. Last slide, please. This is just a summary of what H-Cycle is doing. We are trying to deliver high purity fuel cell quality hydrogen that's cost competitive. We realize that our market, we have to compete with refinery level wholesale hydrogen, which we do. We have to compete with the disposal of waste at a landfill, which we do. And then we just harvest the carbon or other incentives. And that's how we stack our revenues. So somebody asked a question earlier, and I think you can do some rough math on what's the cost of natural gas in your neighborhood, and that can determine what the cost of hydrogen is from historical production technologies. So in California, wholesale hydrogen needs to be around $2 a kilogram. In the Gulf Coast, it's lower because gas prices are lower. Maybe it's $1.50 or $1.25. Those are just the molecule prices for the big oil majors, what they do today. We can be competitive at that. We have a huge pipeline of facilities we're developing. We're using a proven technology. We divert organic waste away from landfill, which in some markets is a very important goal. In some markets, it's already being done. We still think we're making a higher value product with hydrogen versus electricity. And of course, because all of the organic waste is a biogenic source versus an extractive fossil fuel source, it's all a CO2 cycle. So we have a very, very good carbon intensity. In fact, in most places, we're a carbon reduction strategy for technologies. So that's the quick H-Cycle story. again, if you'd love to talk to me or my colleague, Makoto Mizuyama, he's also in the participant list. But thank you all for being here today, and I'll pass it back to you, Jun-san.
All right, thank you so much, Rob. Just trying to slide. Okay, now let's invite our next speaker from ENEOS. We have Masa-san here. Hi, Masa-san.
Okay, thank you so much. Again, thank you so much, Rob, for handing over to me and your quite impressive presentation. And hello, everyone. I'm Masa Kurata from ENEOS Americas. I'm located in New York and in charge of the development of low carbon energy supply in North America. Today, I'd like to introduce our company's activities which correspond to those of its cycle and what we pursue with its cycle. Okay, next, please. At first, I'd like to introduce our group briefly. ENEOS Group is an energy and material conglomerate with headquarters in Tokyo, and I come from the left side company, the affiliate of Energy Supply. We used to be a petroleum refiner and supplier, and still have half of the petroleum product sales share in Japan. But we have announced to turn the rudder toward carbon neutral, and we are now developing renewable power, biofuels, and hydrogen supply. Okay, next slide, please. In North America, ENEOS conducts conventional petroleum business and business development. Again, we are very excited to tell you that we acquired a part of its cycle share in March 2023 through the corporate venture capital company, which is ENEOS Innovation Partners. A member of the CVC is active in Silicon Valley and communicate with early stage startups and make investment in those who have potential collaborative opportunities in the middle or long term. Meanwhile, a couple of members like me in New York and Houston see later stage or project investment opportunities seamlessly correspond with the Silicon Valley members. In the case of H-Cycle, we are handed over further collaborative opportunities with H-Cycle from that CVC. Now we plan to join some hydrogen production project, as Rob explained, on the West Coast, and to make a joint business case in Japan. Okay, next slide. Okay, thank you. ENEOS sees hydrogen as a possible alternative energy and tries to shape the hydrogen supply chain. In this picture, the light blue point is our refinery, and we regard the refinery as a hydrogen hub of each district because most of them are in the industrial complex, which has potential hydrogen consumers such as chemical plants, natural gas power plants, and steel mills nearby. Although a large part of the hydrogen might be imported, we look into some domestic green hydrogen production project, especially in northeastern region and Hokkaido, which is the northern island area. But we don't stick to the color of green and believe that the H-cycle method, which is generally called waste to hydrogen, is a part of our hydrogen source portfolio. In addition, this business model is still a greenfield in Japan, so we expect to obtain a decent business case. As such, now we are working to realize such a blueprint with H-cycle. Thank you so much. It is a finished of our part. So please let me pass to Taku. So could you start your presentation?
Hi everyone, I'm Takumi Yamamoto from Idemitsu Americas. I'm a business development senior manager and I'm based on San Jose. Please next. And next, please. Yeah, let me introduce our company briefly. Idemitsu is one of the largest energy companies in Japan, and Idemitsu Americas is a wholly owned subsidiary. We established Idemitsu Americas in 2020 in order to transform our business portfolio by developing new business and working together with innovators in the United States, as well as reaching the net zero target by 2050. Clean hydrogen is one of the focus areas. We are actively seeking business opportunities. Next slide, please. Let me introduce our asset in Japan and why we collaborate with H-Cycle. We have 7 refineries and chemical plants located in Japan. We are trying to transform these assets into what we call carbon neutral center, meaning that instead of producing conventional fossil-based products, we'll be utilizing innovative technologies and recyclable feedstock to produce clean fuels and materials. And the Japanese government has set a target to supply 3 million tons of clean hydrogen annually by 2030 and 20 tons by 2050. Since renewable cost for green hydrogen is pretty high in Japan at this moment, so most of the clean hydrogen is planned to be imported. However, by utilizing waste as a raw material, clean hydrogen can be produced and supplied domestically. This is a reason why we feel the huge potential of waste to hydrogen business in Japan and working together with a robust H-Cycle team. Next slide, please. In terms of our activities, we have already held extensive discussion with a range of major stakeholders, including local municipalities throughout Japan, in order to secure support for our projects. Actually, many of them showed their interest to H-Cycle's technology. Even though the technology shows high TRL, this is still a new business model in the market. So we'll be engaging with those municipalities continuously. In addition, our existing business activities have strong relationships, not only in Japan, but also in other Asian countries. While it is still early days at this moment, our plans for H-Cycle's waste to hydrogen model include expanding our operations beyond Japan to other developing Asian countries that are facing with serious waste disposal challenges, particularly those with large population. We believe that the partnership between H-Cycle and Idemitsu contributes to supply clean hydrogen and achieve carbon neutral and expand business opportunities from Japan to Asia in the future. Thank you.
Okay, thanks everyone. We're a little bit behind the schedule, so we're just gonna pick one or two questions here. So maybe this is a question for either ENEOS or Idemitsu. What made you guys decide to work with H-Cycle as your partner? Were there any deciding factors? Maybe Masa-san, you wanna?
Yep. Okay. I'd like to answer the question. At first, it is a very basic point, but the produced hydrogen is match to the strategy in the maps of the carbon neutral. The second part is the characteristic of distributed supply. We are the oil and gas company, so that we are relatively good at the large scale production and supply chain, but we should think about the very local supply and the too much those demand. The method of H-Cycle is very good case. So we think that it is complement our basic ability. It is why we choose H-Cycle as the investment destination.
Thank you so much, Masa-san. And next question would be, what is the deciding factor over plant location? Probably this would be a question for Rob, but how do you guys decide where to build your plant? Does it have to be close to landfill locations?
No, it's a great question. We actually like to be closer to the hydrogen demand. It's fairly easy to transport the waste. We already, as societies around the world, do a great job of aggregation of the waste stream. And I want to make it clear to people, we're not trying to go to the landfill and mine materials from the landfill. We're interrupting streams that are going to new landfill. So it's best to be as close as we can to existing feedstock, like a refinery. And then we can move volumes to the emerging transportation sector for direct fueling, which is very high value as well.
Wonderful. Thank you so much, Rob. And again, thank you so much, guys, for the presentations. If you guys could also leave your contact information in the chat box, that'd be great. So if any of the participants are interested in getting in touch with you, they can contact you directly. Okay, let's move on to the next section. Up next, we have introduction pitch by Eavor. We've invited James from Eavor, so maybe I'll pass it over to you, James, so you can talk a little bit about what you guys do.
Okay, thank you very much. I'm just sharing my screen right now. Can you see that okay?
Yes.
Okay. Well, first of all, thank you for arranging this session. I'm more than happy to be here. Now, what I'd like to talk about is what we call the unconventional geothermal revolution. Now, it's well known that the unconventional shale gas revolution or unconventional oil and gas revolution changed the energy world. In the 2000s, the USA was importing LNG, but today the USA is actually a major exporter of LNG. And this change was actually built on the concepts, the business concepts and the technology of the unconventional oil and gas revolution. Now, Eavor was founded on the idea of taking this technology, taking these business ideas, adding our own innovations, and then rolling this out to the geothermal industry. Now, it's hard. It's taken a lot of time and effort to get here, but we found the capital, we found the partners. And these partners like BP and Chubu and Chevron, they came in, they looked at our people, they looked at our leadership, they looked at our technology, and they believed, and they invested in our company and are becoming our partners with various projects around the world. Now, we've done good things. We've received a lot of recognition from industry. Now, our first project on the left-hand side, you see there, it's called Everlight. Now, we built this in 2019. We built it on time, on budget, and with no HSE problems. The one in the middle, we call Everdeep. And that was drilled. It was one of the deepest geothermal directional wells in the world. And it showed that several of our innovations do work and work well. And then on the right-hand side, we've got our first commercial project. It's called Eavor Europe in Garrett Street in Germany. We just had the opening ceremony for it last week, and we had Olaf Scholz, the Chancellor of Germany. He actually came out and joined in our celebration as we showed basically Europe and the world what we are starting to achieve there. Now, I'm going to explain our technology a little bit here. So basically, what we're doing is closed loop geothermal. So instead of traditional geothermal, where you just produce water or gas up out of a single well or several wells, what we do is we circulate cold water down into this network of holes that we've drilled underground that are joined together. The water heats up and then actually comes back to the surface naturally through what we call the thermosiphon effect. We bring it to the surface, and then we can use it to generate electricity or provide heat or cooling for district networks or for factories or schools or any large market for heat or for cooling. Now, this is different than traditional oil and gas or traditional geothermal because essentially there's no exploration risk. It's how a business can plan a project, site it, and then drill it and build it as efficiently as possible. And then once somebody builds one of these, it's easy enough just to slide your operations over a few meters or 20 meters, 100 meters, and then build another one right beside it. So you can actually build these in series until you can fill up the available market for heat or for power. And that means it's scalable. You can roll it out as much as you want. It also has very little environmental impact. We don't use a lot of space at surface, so you could actually situate one of these inside a city, inside Tokyo or Yokohama. We don't use a lot of water. You don't have to put a lot of water into the process at all because it's a closed loop. Basically, the same water circulates, heats up, provides energy, and then goes back down into the earth. And we, unlike solar or unlike, for example, wind power, we actually have a minimum use of rare earth metals, which from a supply chain perspective is actually pretty beneficial. And then we can customize these things to provide exactly as much heat or power as required. And you can also use it kind of as an earth battery to smooth out the peaks and the troughs of other renewable sources like solar or wind. Now, here's what our technology is, how our technology has been changing in the past few years. Our first project, Everlight, now we built that in 2019, on time and on budget, no HSE problems, and it's been operational since that point. And you can actually go out and visit it if you like. In the middle, what you see right there is what our first commercial project will look like in Europe. So we're going down about 4,500 meters and then going out a few thousand meters, to gather heat from the rock quite naturally. But what we're working to is what we call our Eavor 2.0 technology. It'll be a lot deeper. It'll go into hot rock, much hotter rock, and hopefully we'll be able to roll this out to almost anywhere in the world. It's not easy, but we're sure that we can do it safely and efficiently and economically. Now, this is how our technology compares to traditional geothermal. I'm not going to go over this, but I'm sure you'll be able to look at the slides later. But more importantly, our strategy looks like this. So at the top here, you can see that first we're developing our technology. And then we have to build the first few projects by ourselves, gathering partners as necessary. But this proves out our technology. It proves out our processes and helps us build more intellectual property that we can then, and this is the important part, then we can roll this technology out and share it with anybody in the world. So if there's somebody in Vietnam, in Australia, in the Middle East that wants to build an Everloop, rather than having us go with them to do it with our own equity and our own people, we can actually enable other people to just license our technology, borrow it, if you will, and then build these in their countries, for their markets as necessary. So that's how we hope to take this technology, take these business processes, and then roll it into what we call the unconventional geothermal revolution. Okay, thank you.
Thank you so much, James. Now we'd like to move on to the Fireside chat section. And before starting, I want to invite our other speaker, Yuta-san from Chubu Electric. Yuta-san, do you want to quickly introduce yourself?
Hi, I'm Yuta Kano from Chubu, and I'm also the director of the Eavor Technology Inc. and also managing director of the Get Street Project Company. So I'm so excited to show you the strong relationship with Eavor and Chubu. Thank you.
Wonderful. Thank you so much, Yuta-san, and welcome. So I guess I'm going to start with a couple questions, and then maybe you guys can take it away. Maybe you guys could also address some of the questions that are in the chat box, the Q&A box. So the first question would be for you, Yuta-san. I know you guys decided to, Chubu Electric decided to invest in Eavor. If you could touch on what led you guys to deciding if you guys are going to invest in Eavor, or what are some of the deciding factors?
Yeah. In the course of the Chubu's thorough investigation, we found out the number of so-called dry hole in the world. So that is actually failed well for the geothermal projects. due to lack of the steam of the water stream due to low permeability. But there is actually huge potential for the energy source over there. So we just miss it. There exists, but we cannot retrieve it. Based on the traditional geothermal technology. Having said, however, Eavor can do this. So that's a huge reason for Chubu decide to make a partnership with Eavor. Chubu believe that Eavor is the game changer for the future of energy. Using Eavor loop technology, we can actually revive the most of the dry hole in the world, and that is huge, significant scale. So that's the reason why.
Thank you so much, Yuta-san. I know there are like a lot of hot springs in Japan, volcanoes, and much of the geothermal energy goes wasted. So it's great that you guys decided to invest in Eavor. I guess next question would be for you, James. I was personally wondering, I think your project would be pretty capital intensive. You guys basically got to drill up the hole and deploy your closed loop system. Were there any challenges around that, deploying a system overseas, given that you guys are from Canada? Or is Chubu helping you guys in any way?
Yes and yes. There was a lot of challenges to getting our first commercial project off the ground. We found a site in Germany that had a failed traditional conventional geothermal well on it. So that enabled us to understand the geology really well. We knew what was going to be there when we drilled it, and we were able to plan our project based on that information. But however, Chubu has now come into that Garrett Street project, and they offer a lot, particularly on the overall project management and execution side, because as a big company, they've already invested in any number of projects overseas, and they're continuing to help us with understanding how to finance it, how to get these things in place. We have the engineering skills, but a successful big project like this requires much more than just engineering. It requires project management, it requires finance, government relations, everything like that. So it's been tremendously beneficial.
And let me add something. The Garrett Street is the very first commercial geothermal projects using the closed loop technology. And then, naturally, it has the significant challenges. But, once we make it, that is actually breakthrough. And then, that is a showcase for the Eavor loop can actually save the dry hole. And then, that has a strong impact on, expanding, spreading this technology on a global basis. So Chubu decided to go with the Eavor, and then Chubu is talking to the major banks, international banks, and then they also showed the very keen interest to, invest and, to finance this project. So I think the finance-wise now the Garrett Street is getting ready.
Interesting. Yeah, I also see a couple of questions coming in the Q&A box, so wanted to pick one of them. I guess this question would be for James. Which one is that secret sauce that and your competitors do not yet understand? What kind of megawatt hours plants can you build today, and what is your future scaling plan?
Okay, our secret sauce is the idea of making this a repetitive process. Now, and this is what really made the unconventional oil and gas revolution successful in the United States. It's not that you could drill one project and make a little bit of money, or 5 and make some money. It's that you just kept on building and building and building. And every time you build a new project, you get a little bit better, you get a little bit faster. It's called the learning curve. And then that makes the next project more profitable. And then you just keep on rolling these out in the same area. You learn a little bit more, and then you build them in the next area. You do your first project, it's a little bit expensive. You get it in, you're successful, and then you build the next one right beside it, and you're faster and better every time. And now in the United States, you've got tens of thousands of unconventional oil and gas wells. And we're looking forward to having tens of thousands of unconventional geothermal wells all around the world. So that's the secret sauce. That's what's going to make us successful over the long run.
And if I add the scale of the projects and the first commercial project in Germany, that is the electric power wise, the 8.2 megawatt, and then district heat wise, like 64 megawatt thermal. So that is the scale, yeah. And then we can expect getting much bigger and bigger in near future.
Exactly.
Well, yeah, I think we're coming up on time, so maybe let's pick another question and we can kind of close out the session. This one is pretty interesting. Is there a limitation in implementing such facility in earthquake-prone regions or just regions near the edges of tectonic plates?
Okay, now we're building these fairly complex underground structures. There's lots of people in the world that have drilled 4,000, 5,000 meters, lots of horizontal wells in the world. But we're building a little bit more complex underground structures than that. We've got a lot of new technology that'll help us do it. But essentially, we're going to try and avoid active faults. Because if you cross an active fault like that, right there, it's in the camera. If you cross an active fault and then it moves, if there's an earthquake, you're gonna break it, right? So if we're a few hundred meters away or a kilometer or two away from the very active zones, it should be okay. Because during an earthquake, the whole thing shakes at the same time, the same velocity and amplitude, up, down, sideways. So you're not going to have any damage to the well during an earthquake, as long as you're away from the actual faults or that move.
And the Tube actually has a plan, our investment in not only into the Geretsried Germany, but also Europe, other countries, and then on the other continents. And then, we also have the plan to, develop in Japan. So our Tube's partnership with Eavor is a very much global basis. And then we want to, spread this, very much useful technology to the world for the future of the energy.
And the future of the Earth.
Correct.
Absolutely. Well, thank you so much, guys, for the presentation and interesting conversation. And
thank you.
Yes.
Thank you.
And yeah, I know many of you might be interested in getting in touch with them. So we're going to send you guys a follow-up email with the recording and probably the contact information as well. So yeah, this will conclude today's session. Again, thanks everybody for joining our event. And I think it was great content. And we're also planning to do an in-person event on December 4th. We'll send more information once everything's finalized. But again, all the presenters, thank you so much for joining us today. It was a great session.